Well, thank you everybody for joining us. This is WIN307, Security Best Practices for Microsoft Workloads. My name is Mark Shalkevich, and I am with AWS Professional Services. I'd like to introduce you to my peer and my co-presenter, Manu Durapande, who is a partner solution architect with the AWS partner team. So I'd like to provide some guidance and kind of navigation of what we're going to be talking about for the next hour or so here. And so what we're going to do is we're going to provide you an overall holistic approach and overview to security for information systems that we have here. From there, what we're going to do is we'll drill down a level and we'll show you some of the AWS native services and features that can be applied against that framework that we're going to showcase for you here. We'll talk about some monitoring and logging as well. We'll try to bring this home for you with a couple of show and tells, actually demos for this. Hopefully those will help get the point across. And we're going to sprinkle in some general guidance for best practices as we go throughout the session. So with that, let's talk about this high-level overview and end-to-end security. So what we've done here is we've actually selected a number of mechanisms and controls that could be used as security safeguards, as well as security safeguards in order to minimize the risk to your systems. Now, when you look at these, there are 6 pillars, but I actually grouped these into 2 sets of 3. And these are ones that Manu and I had actually come up with for this discussion. So on the left side here, your left, we have the 3, which I consider the mechanisms in terms of identity, infrastructure, and data protection. The preventative, detective, corrective are the controls that we're going to be talking about. So from the identity perspective, what we're talking about is the access into your systems, right? The provisioning and the deprovisioning of users and accounts to get into your systems, how to manage those, and how to allow access into the systems that you want. We move over to infrastructure security and how to protect your environment inside. So from an AWS perspective, talking about protecting your instances, talking about protecting your network, whether it's NACLs or security groups, things like that. And then data protection, how to prevent unauthorized access to your data. And as important is how to provide the appropriate access as intended to the users that you need or to the applications that you need. So let's spend a little time on the controls. So these controls actually, controls can be categorized by the criteria by which they're defined. So for example, they can be defined by their nature. And by their nature, what I mean is they can be physical controls. So something like a room that your Bastion hosts are locked in, so that's a physical control. We can talk about procedural controls. So something like management oversight, security and awareness training, as well as incident response could be classified in that. Again, that's part of the nature. Next, we have technical controls, as we talked about identity. So providing access into your systems. You talk about providing antivirus software in your systems. You can talk about putting firewalls in there, which are technical. And then, of course, we have legal controls, compliance controls, and/or regulatory controls. An example of that is privacy. Another example of controls can actually go along the lines of what we talk about with information security. And there, what we're talking about is the people, the technology, and the processes that are involved with the operations. And then they're categorized into confidentiality, integrity, and availability. For the context of our discussion, what we decided to do was we're going to take a time-based approach to this. So what we're looking at is actually the preventative, detective, and corrective controls from this. So when you looked at time-based, this is really about prior to an incident, during an incident, and after an incident, what happens. And when we look at the preventative controls, again, identity comes in. Before an incident occurs, you can take measures to ensure that you can counteract something. So you provide policies for access. You can provide appropriate groups that you're going to put in there, authentication mechanisms, things like multi-factor authentication. Detective controls are the ones that actually occur during an incident. What do you do when an incident occurs and the response that you take from that? So you pick up the incident, you categorize the incident, and you determine what you're going to do with that incident. So for example, you may shut down ports. You may just log it. You may run some scripts for it. And then we move over to the corrective controls. And the corrective controls are what do you do after to maintain business operations and how quickly you can do that, as well as minimizing any type of system impact you have from any of the incidents that have occurred. And what I like to think about also is a feedback loop from the corrective controls to the preventative. So if something did occur and you've got to take that corrective control, that you can actually feed that back and take care of it in preventative control. So if the incident occurs again, you've already got it covered. So with that, that's going to be the focus of what we're talking about here. And what we did was also mapped out AWS native services and features below each of these pillars that we find mapped to each of these areas here. Now, given that we only have about an hour, or less than an hour for these, we can't go through the approximately 28 services that are here. So we boil these down to 4 pillars that we want to talk about, and approximately 8 of these here. So I don't want to have to read, you can see them yourself. I'll be talking about AWS Managed Microsoft Active Directory, AWS Single Sign-On, we'll talk Systems Manager Inspector, and things like that. Now, I do want to showcase that the icons that you see up here are going to help us navigate through this presentation as well. What I mean by that is, when we're talking about infrastructure security, you'll see that emblem up at the top right corner, so you know exactly what we're talking about. We start with identity, we'll have that badge up there as well. So with that, let's start with securing identities. I think everybody knows about Microsoft Active Directory, and what we have is AWS Directory Services for Microsoft Active Directory. Also, we refer to this as AWS Managed Microsoft Active Directory. What we do is we provide Active Directory as a managed service to you. This is inherently Windows Server 2012 R2 that we provide as a managed service. This is absolutely Microsoft's directory service. They run for identity and access management. They provide the service where you can provision, deprovision users, you can manage your users, you can apply groups, you can apply group policies to do that. Exactly what we're doing, except we're managing it for you, making sure that it's available, that it's reliable, updates are taken for you, or done for you, and we handle all of that stuff on the domain controllers, so you can handle the administrative portion of your users and your groups and security aspects of your security principles as well. So there are 2 editions that are available for this, Standard and Enterprise. Depends on the instance that's used, really. And so the Standard will go up to about 5,000 employees, and the Enterprise version will go up to about 100,000 employees for you. Okay? And we can see the AWS Managed Microsoft Active Directory actually has native integration with some of the AWS services, Microsoft SQL Server instances, Amazon RDS, Amazon EC2, AWS Workspaces as well. For completeness, I wanted to mention Active Directory Connector. This is actually a proxy service. So you have an Active Directory on-prem, or your on-prem Active Directory, and you'd like to access the AWS console. You can actually use AD Connector as the LDAP proxy to that, so you can do the authentication through that. We won't be talking about Simple AD. Simple AD, again, for completeness, is basically Samba, but I just wanted to highlight it there for you. So why are we talking about Microsoft Active Directory at that high level in the security session? So the way that we invoke this is when you set up the managed directory for yourselves, you get minimum of 2 domain controllers in separate availability zones. We provide a security group. Now, you don't get the DCs. You cannot access these domain controllers. You get network interfaces within your VPC that you can access. And what we do is we apply security groups to those ENIs, those elastic network interfaces. The only communication that's allowed is communication that is required by Active Directory in and out of those ENIs that bridge the gap from our control plane in the back to your VPC. Excuse me. This is inaccessible from the internet. If you want to get to your directory, you have to be within your VPC to do that. That's why you typically need a Bastion host to get in there, or any other systems to get in through your VPC to that. Even if you change your routing tables, if you play around with the network adapter, if you set up a NAT gateway, you cannot get to those DCs. You have to do it through a remote desktop gateway or use server tools, or RSAT tools, something like that, excuse me. Now, you can modify the security group rules, and you can make them more restrictive. Right now, they're open everywhere. So they're open fully. So 0.0.0/32. So you can actually restrict that down. So anything that communicates, as well as you can restrict the destination addresses that DCs can communicate with. Excuse me. Was that something bad for lunch? Let's see, did I finish on that slide? Yep. So just moving on to AWS SSO, single sign-on service. What is it? Basically, it's a cloud-based single sign-on service that we provide. You can centrally manage access to multiple AWS accounts and cloud applications. So from the diagram, you can see that we can do multiple AWS accounts. You can go out to any cloud-based applications, Dropbox, Office 365, and you can base it on the users in your Active Directory. You can connect the SSO to your on-premises Active Directory, use the security principles there. This way, you really don't have security principles sprawl, where you have to actually have your security or your users inside AWS, for example, and also have them in Active Directory. So what you can do is, as we're talking about automatic AWS CLI console access and permissions based on the group, if you set up a group in Active Directory and you place your users in that group, and you set up the roles on the AWS side matching that group, the SAML assertion will capture that, and it'll actually provision the users for the right permission sets that you have. So for example, developers that are in a test environment in an Active Directory group, you provision them into that group. When they get into AWS with single sign-on, they have the right permissions just to do their work that they're provisioned for. So we can also provide audit and access to multiple AWS accounts for this. It's integrated with third-party tools like Splunk, Sumo Logic. The other thing that was just released recently was SSO supports its own directory. So you can actually create your own users and groups in SSO, and you can actually provision them for application access as we, as we have this. So again, what we're going to be doing here is providing a demo for this. And what I'd like to do, I want to explain the demo. We tried to keep it very simple because this may get, sometimes demos get a little convoluted. So we're going to be doing what the diagram here shows, is we set up an on-premises Active Directory or pseudo Active Directory, which we have on an EC2 instance. So we're not using managed Active Directory. We stood it up on EC2. We created a user inside that group. We've coupled AWS single sign-on using AD connector to that directory. And we're going to show you that we can keep a user that's not provisioned. We've disabled that account that cannot get into, for example, Dropbox we're using or AWS. We will enable that user, and it will provide you the access. So we can show that you can provision a user into the cloud, and you can do this at scale if you want with various mechanisms, whether it's scripts or however you might do that. So I think everybody will understand that, so why don't I get to the demo? Excuse me, my voice is going here. Oh, great, logged off. Awesome, worked. So let me just take you through this, and unfortunately I have to put my glasses on. Is that up there? Oh, awesome. So what you can see here is we set up the SSO already for you. And so this is going to be actually the link that we're using SSO, and that is over here. So that's going to be our sign-on page. That's going to take us into AWS console for a user that's provisioned for that, as well as a cloud-based application. And this really takes just minutes to set up. The directory service that we're using here, you can see we're going to be connecting into this account here. That's a domain controller, the 166 address that you have there. So we're going to go directly into that via the AD connector. So what we did was we created a jump box or a bastion host. That's what's in orange here. So we're RDPing into this bastion host. And then you could see the other RDP session from the bastion host which is the screen in black that we're going directly into the domain controller. Now again, if this was a managed Active Directory, what you'd have to do is actually use RSAT tools, remote server administration tools, to actually get in there. But for the purposes of a demo, it should work out fine. So you can see here that we're on the on-prem .NET domain controller, or domain here. And again, we're going to provide this user here, simply in this user group. And you can see user SSO, that's what we're going to be testing with. And you can see the little down arrow, that means it's disabled. And we can kind of prove that with, it says enable account. So we're kind of pseudo-stating that this is a non-provisioned user yet at this time. So if we go in and we go to our other screen here, and we try to log in with that user, and this is the password that's there. I can type it in. I can show you. We get an authentication failure. The account is disabled or it doesn't exist. If I put in another account here, 222, and we try to do that, it's going to just not do anything again. There we go. So let's go back. We'll enable that user. Okay. Which kind of represents that we added a user, we provisioned a user there, and we put them into a group that'll be accessed there, and take those SAML assertions to get in to AWS. And let me get back here. I really like refreshing the page. We have our user SSO. No sleight of hand. I'm leaving that password there. And so now you can see that we have, now you can have a whole list of applications and things that are going here. So we just wanted to demo that you can go into the AWS account. So that SAML assertion is going to take AD groups that user is a member of that are mapped to roles inside of AWS. So you can just manage that user on the Active Directory side, whether it's your on-prem user, your on-prem directory, managed Active Directory that we're managing for you, or an EC2 instance of that directory. So they're going to come into that user. And we selected Dropbox just to show you a cloud-based application that you can get into. So let's just get into Dropbox first. We click that user. And so you can see that we're there. We didn't set up an enterprise account with Dropbox, so we just wanted to show you that we can actually get in there to give you that access. And then we get into AWS accounts. I'm checking my time here. You can see that we have the user here. Now, if there were more roles associated with that user, you'll see them drop down here that you can select, and you get administrative access. Kind of click that one right there. And now we're getting into the AWS console. And again, the user that's getting into AWS is in Active Directory somewhere else, and it's being provisioned up through SSO, that they can come in, they can do their work based on the permission sets and rules that they were given inside of AWS as well. Now, to drive that point home, let's just go back here. I'm going to deprovision that user. And we'll disable it. So let's just say an employee left and you had to get rid of that employee. And you can do this at scale with whatever mechanisms that you do this in your environment. So again, that user is disabled here. We'll do a refresh on this. And we'll look to sign in. And again, can't get in. So it's automatic. So, and if you have a list of cloud-based applications, if you have Salesforce up there, things like that, you can do this across the board for all of them. So all your users have this single sign-on access based on a user identity that's inside of Active Directory. Okay, and this way you don't get user sprawl. You don't have to manage users in AWS. You don't have to, you can manage them in one place. So with that, my part of the speaking is done, and I'm going to hand this over. Let me turn this back to Manu, who's going to take you from here.
Awesome. Can I get the clicker?
Oh, yeah. There you go. Thank you. And let me just disconnect here.
Fantastic. Good afternoon, and welcome again to WIN307. My name is Manu Duraipondi. I'm a senior solutions architect. I'm part of the AWS partner team. that focuses on running Microsoft Platform workloads on AWS. Mark and I realize we are probably the only two people standing in your way of getting a beer or going into pub crawl. So we promise we'll get you out of here on time. And I have about 40 minutes left in this session, so I'm probably going to end up using all 40 minutes. So Mark and I will hang around after the session, and if you guys have any questions, we are happy to answer them after the talk here. Wonderful. So let's get started here. I want to quickly bring your attention to the top right-hand corner, as Mark mentioned. So we are now in the infrastructure security section of the talk. And I want to talk about a service called AWS Systems Manager. It's been around for a while, albeit under different names. It used to be called Simple Systems Manager, EC2 Systems Manager. But in its current form today, it is made up of 7 different actions, or 7 different features or capabilities, if you will, however you want to look at those. And the most recent addition to that AWS Systems Manager portfolio is the distributor action that was added less than 10 days or about 2 weeks ago. So we are going to focus our talk on the left-hand side of the screen here, but I'm going to probably be touching on State Manager, maintenance windows, and automation here and there. But the primary focus here is just Session Manager, Run Command, and Patch Manager. Just a quick show of hands, how many of you guys today actually are using Systems Manager, AWS Systems Manager? Okay. Maybe about, I want to say about 5 to 10% of the room uses it. So hopefully by the time you guys walk away from this, maybe you guys will look at this as a useful service to go put it to use for your Windows workloads. All right, cool. So let's get started with Session Manager. So I want to talk about 3 important points about Session Manager that makes it so important for the security of your Windows workloads. The first reason I want to talk about is if you decide to use Session Manager to connect to an EC2 instance, then you don't have to create or distribute public and private key pairs. So when I say connect to an EC2 instance from Session Manager, what I mean by that is connecting to a Windows instance via PowerShell command line interface. That's what Session Manager does today, right? So when you do that, you don't need to distribute any of your keys to your users. Your users can come to Session Manager, and then they can jump onto any Windows instance they want to in that account, right? So that's the first point there. The second point I want to talk about is Session Manager, access to it is controlled by AWS Identity and Access Management service. So if you decide to use Session Manager, by using AWS IAM, you can actually control and manage in one central location access to any specific instances that your users or groups of users have access to. Meaning you could control the access of your users by creating IAM users and policies so they can only log into a certain Windows instance and not log into other instances. And it doesn't stop there. The other point here is when you actually create access or give access to these users, you can control the SSM API endpoints or the API calls these users can make to these Windows instances. Again, the API endpoints are still under SSM, meaning Simple Systems Manager, but it's AWS Systems Manager, right? So that's the second point. The third point here is actually the cool, the cool point, and I think it's a really important point here, is as the diagram here shows, a user comes in, has IAM permissions to use Session Manager, gets on Session Manager, and actually has access to an EC2 instance and goes into an EC2 instance. But if you see, that EC2 instance can be completely locked down from a security group standpoint, meaning you don't have to have any inbound rules to that security group associated with that EC2 Windows instance. So it's like completely locked down. So from that standpoint, you are actually reducing the attack surface of your Windows instances. Therefore, it minimizes your threat landscape this particular Windows instance is actually exposed to, right? So to drive this point home, I have a live demo that we are going to do. I'll try to, in the interest of time, I'll try to talk and I'll tell you what the demo is all about. So basically what I'm about to do is I'm going to log into my AWS console. I'm going to show you, randomly pick an EC2 instance. I'm going to show you the security group associated with that instance has no rules at all. And then I'm going to jump into Session Manager, and then we're going to connect it to that instance. All right? So let's do that demo.
So flip it, and I connected you already.
Cool. flip it.
Yeah, go to the next one. Yeah.
There you go. So Mark, remember we were talking about live demo God prayers? You can start them now.
Mine were answered. Not sure about yours.
And Mark promised that he'll do tap dance while I'm trying to get things going. So, all right.
I might
cool.
sing.
So we are in now. So I'm going to log in. So this is my AWS console. And, you know, so let me refresh here just to make sure it doesn't time out. Of course, it has timed out. So let's get back in. So you're in the Northern Virginia region. That doesn't matter. But I have to randomly pick an instance, but I'm not going to disappoint that instance. So I'm going to definitely pick that instance, right? So obviously, any instance you launch must have at least one security group associated with that. So let's look at that group. Oh, the group says SG with no rules. But you guys are not going to believe me, right? So let's do this. So I'm looking at view inbound rules, no inbound rules. So I'm actually going to hit that security group right there. That's the group. And absolutely no inbound rules, right? And if we go back real quick, I wanted to point out another fact here. This instance just has a private IP address. Absolutely no public IP addresses. And also, this instance happens to be inside of a private subnet, meaning it doesn't have a direct route from the internet. It has a route to the internet through a NAT gateway. That's how this instance is set up. All right, so now I'm going to jump to Systems Manager console, which is where Session Manager lives. So I'm going to try and open this in a new tab because all other tabs must have timed out. And let's go to Systems Manager, right? And here's Session Manager on the left-hand side. Let's click on it, and you're going to see a blank page open up, and there's going to be a button if the demo gods really answered Mark's prayers. Looks like we're halfway through. So you're going to hit Start Session here, and then it's going to pull up a bunch of sessions that you could potentially start. So these are basically called managed instances that are within the Systems Manager console. So I'm going to, again, not disappoint that instance. Looks like it's erroring out already. So let's refresh again, maybe give it about 30 seconds, and if it doesn't work, we'll move on. But I'm going to try and pick that and click Start Instance, right? So this is going to basically take you into that particular instance. If you see the instance ID, it's ending in 2583. And if you go back here, that instance ID should be 2583. So we are logged into that particular instance, right? And now, so some of you might be thinking maybe a Systems Manager, Session Manager really using Windows Remote Management or a service that runs under the name WIN307. So I'm going to go ahead and see if WIN307 is running. So let's look at get service, and the name of the service is WIN307. And I'm just tabbing it, and then it automatically picks it up. So it's actually full interactive mode, right? It looks like the service is running. So what I'll do is I'll actually stop this service, right? And let's make sure this service is actually stopped. Now, WIN307 runs on TCP port 5985, so I'm going to do a quick check to see if there is anything else running on 5985, 5985. It's empty, but I'm still connected to that particular instance, right? So just to prove a point here, I'm going to terminate this session, and I'm going to get back into the same session to show that there's no WIN307 even running on that particular service, on that particular instance, but I'm going to go ahead and start that session, and I'll still be able to get back into that instance. So we are back in, and if you go look at get service name WIN307, it stopped, right? So what is really happening here is Systems Manager actually has an agent called an SSM-user agent that's actually running on all of these Windows instances. So how did it get on there? So if you installed, or if you hydrated, or if you brought up a Windows instance based off of an ARMI that was released after November of 2016, those SSM user agent were automatically added to those Windows instance AMIs, right? So this particular SSM user, by default, gets added into the local administrators group of this particular instance or any Windows instance, and that is what the SSM service is actually talking to and getting all of that stuff back to you in the console. So if you go look up the local group here, administrators, you should be able to see that SSM user dash user in there, in its members. So of course, you can take this and put it into a different group, but the default behavior is it's going to be there. So this is the end of the demo here. So I'm going to switch back to my slide real quick. So I want to go back here. So one more thing I want to point out, you see that SSM endpoint, that is an optional endpoint, meaning it is a private endpoint you can create within your VPC, and basically SSM will talk through, or your VPC EC2 instances will talk through that conduit that you've established in your VPC back to the SSM service. That way, none of your traffic that exits out of your EC2 Windows instances get out in the public. It's actually it's still on Amazon backbone, but it's on the private backbone, right? So you can actually detach your IGW and lock all of your instances very safely and very securely inside a VPC if you decide to use Session Manager. Cool. So that brings up to something called run command. Again, it's an action or it's a capability. It's a feature of Session Manager, right? So run command actually has been around for a while, right? So run command basically has two major talking points going for it from a Windows security standpoint. The first point is basically the way run command works actually lends itself to great security practice for running Windows instances. The reason why I say that is run command uses something called a document. And that's what I call it, a curated document. I call it a curated document because those documents are written by you, or you can use a default document that is already published to you in your account by Amazon Web Services, right? So it uses this document. What is this document? This document is just a bunch of commands, right? You can go put the netstat command I put it in. You can take that command, you can wrap it up into a document, and that is the only way this run command is going to execute. What does this do? Because this is a curated list, and because this is a vetted list that you created and put it into your own account, none of your systems engineers or ops engineers or whoever that is managing these instances, first of all, they don't have access to your EC2 instances. Second of all, when they're trying to install something, they have to go through this curated list of documents, right? So you control what they get to do, when they get to do, on what instances they get to do, right? This is a pretty powerful feature, right? And I don't want to get into the details of how many kinds of documents are there, but just understand there is a document called command document. That command document gets to go with the run command and state manager. The second point, I said two major points. The second point is, if you look at the right-hand side of the screen, the output options. So you've rolled up a bunch of commands into a bunch of documents, and now you've sent it out to execute against Windows instances. What happens to the output, right? So you've got a number of choices there. So the first choice, of course, is you can look at it from AWS console. You won't get the full console output, but you will get a few lines, and you will see if the command executed or not. That's one option, right? The second option, of course, you can send it to S3. That's very powerful, because now you know what commands you executed against these instances and what really happened to those commands after it got executed in your Windows instances. That is saved for audit purposes, and that is saved for historical records and compliance reasons, right? So that's perfect, right? The third option, of course, you can add, you can do this all together in one execution. The third option is by using AWS Simple Notification Service, or SNS, you can actually get notified. Maybe you want to get notified if the command's really completed, or maybe the command's timed out, or maybe the commands are in progress. Maybe you want to alert an ops team to say that this particular installation is complete, right? So SNS endpoints. And of course, the last point is you can send it into CloudWatch as well. So those are the top 2 points why run command also lends itself to great security practice for Windows instances running on AWS. Cool. So let's move to the next slide. So we spoke about Session Manager. We spoke about run command. Of course, run command's been around for a while. Session Manager is, I believe, 2 or 3 months old, fairly new service or fairly new feature of a service. So when do you use run command versus when do you use Session Manager? Right tool for the right job. The first rule of thumb is if you're trying to execute commands across a fleet of Windows instances, then your tool of choice is run command. I want to touch 50 instances. I want to touch 100 instances. I want to touch thousands of instances. I want to run this particular whatever command. Maybe I want to run a patch, or I want to install an application like Docker across 50 instances for this particular application, then go to run command. When will you use Session Manager? If you're trying to log into a box, a Windows instance, and if you're trying to dive deep into troubleshooting something, or maybe the CPU spiked and you want to see why this process is chewing up so much CPU or so much memory, you want to troubleshoot, you want to do a deeper analysis on a single instance, you use Session Manager, right? The second point there on the right-hand side again, Session Manager, of course, gives you full interactive mode. Color-coded errors, you tab it, you pick up service names and commandlets and et cetera and all of those things. You don't get to do that in run command. And to the left-hand side, if you see, there are two things that work in favor for run command when you're comparing it against Session Manager. You can use concurrency control and you can use error control. What do you mean by concurrency control, right? So when you're executing a command, you can set a threshold for concurrency, either an absolute number. Let's say you're executing against 10 instances. You can say 5 at a time, or you can say 50%, right? In either case, it'll basically go and choose 5 instances. And the way it actually chooses those instances are actually interesting in the sense that it goes and executes this particular command on one instance, and then increases to 2, and then goes exponentially 4, 8, and until you hit that threshold, concurrency threshold. So basically, it's how fast do you want these commands to be executed. So concurrency, if you're executing against a large number of EC2 instances, obviously you're going to set a very high threshold. Error control, very similar. You're going to use error control to say, when do you want to stop executing these commands because of errors, right? So if you set your error control to 0, the very first time it encounters an error, it stops executing your commands. That's it, right? And same thing, you can use absolute numbers, and you can use a percentage of the EC2 instances that you're trying to touch. So those are the few basic differences between the two and when to use session versus run command. All right. Now we get to talk about the very exciting topic of patch management. If there are systems engineers or patch engineers in the room, everyone will tell you it is not a glamorous task. It is a very mundane task, but that has to happen like clockwork routinely, right? Failing to do so, you will sooner or later have overarching security implications. That's how important patch manager is, right? Or that's how important patching is. So in this slide, I really want to introduce something called a patch manager, another action or another capability of systems manager that you can potentially use to push Windows operating system related security patches and updates. It's a really super easy tool to use, and it's fairly effective when you use patch manager. The reason why I say that is if you've already started using systems manager, you've already met most of the prereqs, you only have 3 things to set up to start using patch manager here. The first thing, of course, is a patch manager supported operating system. The good news here is patch manager supports Windows 2003 all the way up to Windows 2016, R2 versions included, right? So all of your Windows operating system versions are covered. The second thing you need is something called a maintenance window, because when you're applying patches, sometimes it reboots, sometimes CPUs get locked up, so you need a maintenance window. How do you actually create a maintenance window? Maybe you've guessed it already. You use a service or a feature called maintenance windows, right? So you'd basically go to maintenance windows, set up a maintenance window, and you'd basically pick the right operating system. And the third thing you need is actually a patch baseline and a patch group. Patch baseline is basically all the patches you want to install or all the patches you want to reject. So you can do that based off of KB articles, or you can go and pick all critical, important, whatever you want to do, or you can even do that based off of Microsoft Security Bulletin IDs as well, right? So you can use that, and you put all of this together, you need a patch group, which is a group of EC2 instances that you want to push these patches to, right? So those are the 3 things you need. Patch Manager here uses Microsoft's WSUS scan2.cabinet file. So if you go look at it, it says WSUS scn2.cab, which is a cabinet file. And that cabinet file is maintained in every single AWS region independently of each other, and they refresh it at least once, again, independently of the regions that they are in. So that's what it uses to pull up all of your security patches, and then you can push it into your Windows instances. And I've added State Manager and I've added Run Command. The reason why I added that was State Manager, you could set up a policy document called policy document. What it basically does is it will basically enforce a certain policy. For example, if you want to, let's say if you want to take a software inventory of all the software applications installed in your Windows, a particular Windows instance, you would probably go to HKey, local machine, software, and you would basically look at what's there, right? So the state machine actually has a policy that will actually go monitor all of this and tell you what software is actually installed, and maybe you want to patch that. Of course, you can send it to Run Command, and you can basically keep that cycle going for you when you're trying to manage Windows instances. And about a week old or maybe 10 days old, State Manager natively integrates with PowerShell DSC. What that really means is PowerShell DSC has 800 community-driven, community-contributed PowerShell DSC scripts in there. You can dip into any of those 800 scripts, and you can pull it into State Manager and have that do something for you. So you don't have to start from scratch or write anything. There's lots of stuff available to you already. Cool. So I don't really have a systems manager demo, but I can show you a systems manager demo. Let's quickly show a systems manager demo here. I'll swap to the screen. So we are basically looking at multiple. These are the 7 actions I was talking about, right? We spoke about run, session, and patch manager. Of course, I briefly touched on my maintenance windows and state manager. But here's the documents I was talking about. You go into these documents section, and you see a bunch of documents. There are actually over 90 documents in there, so you don't have to go create any of these documents. And these documents are specifically written in YAML or JSON, right? But if you go look at it, there's different kinds of documents in there. So if you go do command, document types, you'll actually see command and automation and policy. Command goes with run command and state manager. Policy goes with state manager. Automation goes with automation manager. But if you see there is no distributor policy, that's actually coming. So eventually you'll see a distributor policy in there as well that will let you, use distributor action from systems manager. With that said, we'll dive into our next slides. That was my quick demo of Systems Manager. I don't think they updated the slides. All right, cool. So vulnerability management. So now you've got Sessions Manager going for you. You have completely locked your Windows instances down. You're using Sessions Manager to log into it, or you're using it to do whatever you want to do with your Windows instances. You have Run Command to touch multiple EC2 instances. You've got Patch Manager going for you into this Windows ecosystem where you're actually patching it, and you're doing software inventory control and all of that good stuff, right? Now, most typical enterprise applications that run on Windows environment have multiple third parties or multiple KBs, multiple patches, multiple services that make up that operating system, are inside of that enterprise application. And what ends up happening when you run an application for 3 years or 2 years or 5 years or 10 years, lots of vulnerabilities, publicly known vulnerabilities that got introduced kind of creep into these enterprise applications. They're in there. But the enterprise applications, people running them are blissfully unaware, or maybe it's too hard for them to deal with it, so they can't really deal with it in a very efficient fashion. And this is where Amazon Inspector comes into play, right? Amazon Inspector is an agent-driven assessment rule packages. It's a bunch of assessment that you do across all of your Windows environment to see where you stand in terms of industry standard benchmarks or publicly known vulnerabilities that have been advertised or that have been recorded and put up in common vulnerabilities and exposure CVE that is run by MITRE.org? Or do you want to do Center for Internet Security's benchmark? Where do I stand from this benchmark? What is my standard deviation of this Windows environment when I compare it to the CIS benchmark? That's what Amazon Inspector really tries to do. So there are 5 total packages, or 5 total assessment rules packages that are inside of Amazon Inspector as a service. Out of those 5, 4 of those packages are applicable to Windows. Right? There's one package that is not applicable to Windows operating system, but 4 of them are applicable to Windows operating system. Out of those 4, 3 of those are agent-driven, meaning you need an Amazon inspector agent to be installed on your Windows instance, and of course you know how to do that now. You would go do a run command, and there is also already a command that goes and installs Amazon inspector on multiple EC2 instances, right? So that's how you would do that. But the important point, the diagram at the bottom of the slide there, the important point I want to really drive here is Amazon Inspector allows you to get this vulnerability management into your development and deployment lifecycle. What does that mean? Usually, you stood up a Windows environment, you put it into production, now you're worried about vulnerability management because it's really an afterthought. But Amazon Inspector lets you actually go hard on your AMIs when they are created, supply or give those AMIs to your developers, and their entire development happens on hardened AMI. So it actually gets built into your development lifecycle. It's a one-time effort. You create that golden AMI. You put Amazon Inspector into that equation. Out comes fantastic AMIs that are hardened from an Amazon Inspector perspective. So I spoke about 4 packages. I mentioned 3 of those. One is the CVE, Common Vulnerability and Exposures. One is the Center for Internet Security Benchmark. And the third one is Runtime Behavior Analysis. Insecure ports like Telnet, or maybe you have 3389 open to the world, all of those things will be bubbled up when you run those assessments. The 4th one is the newest one, and this 4th one is actually agentless. You don't need any agent to run on your Windows instances to gather insights, but this is not about hardening your AMIs, this is about hardening your network security, right? So this, what it does is, it runs across your network, and then based on automated reasoning, what that really means is, if there was an instance and had a publicly routable IP attached to that instance, what it'll do is, it'll analyze every single fact surrounding that particular instance. Does it have a security group rule that is permissive enough to run traffic into this IP? Does it have a NACL that is permissive? Does it have an IGW? Does the routing proper? And then makes a decision based on all of those data points it sees in your network, and makes a recommendation saying, hey, this particular instance has port 3389 open, has a public IP, and has an internet gateway, and routing works, so this particular instance will actually be available on the internet, right? Based on that finding, you go do something about it. Think about it, right? You design this VPC, you put a bunch of Windows instances 1 week ago, and then someone released something in there, now that environment is completely changed, or 3 months later, 6 months later. When you run this assessment, you actually go make sure the configuration drift for your network configuration in terms of security has not happened. And if it has happened, you catch it. Does that make sense? Cool. And this is agentless. And this is, I think it was released about, I want to say 20 days ago. Cool. So we just left the infrastructure security section of our talk. Again, if you see up top right-hand corner, you will see we are now in the detective controls section of the talk, right? So detective controls is necessary because of the reason, in reality, every systems engineer, every security engineer always wants to prevent from something happening before it becomes a security incident or a security event for them. But ideally, in real world, it doesn't happen, right? So things happen, but when they happen, you at least want to be notified that something happened so you can actually go do some action to prevent or mitigate against that particular security incident that just happened, right? And this is where detective controls really come into play. And I put up CloudWatch there because CloudWatch is the native AWS service for gathering logs and monitoring, right? And CloudWatch integrates with all kinds of Windows logs. You can have IIS logs, SQL logs, perfmon logs, Windows event logs, VPC flow logs because you're running on in a VPC in AWS. All of these logs can be pushed into CloudWatch, right? Once you receive all of those logs in CloudWatch, you've got a bunch of tracks you can take. What do I really want to do with these logs now, right? I've got CPU logs, I've got, SQL is spiking, whatever logs, right? So the top 3 tracks, right? There are 4 tracks really, but I'm going to talk about 3 important tracks here. The top one, of course, send it to S3, write it to Glacier after a while. You've got audit, compliance, historical records, all of those covered. Legal, everything is covered. If you come to the middle, you've got auto-scaling. And oftentimes, auto-scaling is thought of to be an availability and performance combination to scale up and catch your traffic. It is true, but auto-scaling is never thought of as your first line of defense when you're being DDoSed, right? That's what you want to do. You want to scale out and you want to be able to catch. You're not fixing any vulnerabilities there. Whoever is DDoSing you is going after that vulnerability, but at least you're scaling out and catching that. It gets your security engineers the valuable 10 minutes or 15 minutes when you're under volumetric attacks, which are up to almost 39 or 40 minutes now, right? So you have to be able to withstand that 40 minutes. And how do you do that? You're getting logs and you're doing something about it in auto-scaling using CloudWatch logs, right? And the third option here, I'm gonna pause for a second here and talk about it maybe in very brief terms, because we've got a couple slides towards the end of this deck where we talk about config rules, and Lambda. But basically, it is, you can take those logs and you can do something actionable in an automated fashion. That's what config rule does. We'll talk about it in detail in about 5 minutes or so. I want to talk about another service that sits squarely in the detective control space. Relatively new service, but been around for almost a year, if I remember correctly. It's called Amazon GuardDuty. Think of this as a threat intelligence based intrusion detection service, right? So this is basically not enabled on your Windows EC2 instances. This is enabled at your AWS account level, right? And you can enable it across multiple accounts, and you can get insights delivered to this particular Amazon GuardDuty console. Absolutely no agents to install, no devices to set up, no port monitors, none of that stuff. You just go do a few clicks, and then you're basically up and running, and Amazon GuardDuty starts working for you, gathering all those insights from within your account. So how does it really gather those insights? What does it really look at, and what does it really do, right? So it looks at three major logs, or it looks at three major logs from your account. So the first one is VPC logs, flow logs. It looks at it. Even if you haven't enabled VPC flow logs, it'll automatically pick up those from under the covers, and it'll analyze that. Second one is the CloudWatch Trail CloudTrail events log, and it'll look at that. And of course, the DNS logs that are all generated from within your AWS account. It looks at all of these logs, and it compares it to the threat intelligence that AWS security has built upon running multiple regions across the globe. So basically, if there is a malicious IP actor out there in Romania doing something, or somewhere in the globe, they know that particular IP address is up to no good, and they can use that and see, oh, I'm seeing the same IP here being spoofed and used here, so maybe that intelligent reasoning is done by Amazon GuardDuty, and it basically bubbles it up for you, right? So if you look at it here, it basically caught a port 3389 open to the world in a Windows instance, and someone from Latvia was trying to do a brute force attack on it, right? That's what it does. It basically does, okay, it basically says, oh yeah, so someone's trying to attack you, you may want to do something about it, right? It is intrusion detection service. It doesn't do anything for you, it doesn't prevent you, but it basically detects it for you so that you can go do something about it. Cool? So that's Amazon GuardDuty, and this happened, right? Someone opened it up. It may not be 3389, it could be 1433, it could be 3306, it could be 25, it could be 22, it could be anything. This happens a lot, right? You're trying to go 500 miles an hour, you're trying to set up something because you have to meet deadlines, and you can't connect to it, so you just open it up to the world so you can quickly connect to it or do something, or you inadvertently do it, or you maliciously do it too, within a company, right? So what do you do when this happens? You can do, if you're running on AWS, you can do two things, right? You can either say, oh, this happened, I'm going to send an email using config rule, I'm going to wake an ops guy, and the ops guy is going to go deal with it, right? He's not going to like you, but that's what, you could do that. Happens. Or what you could do is, you can actually go write a PowerShell script in Lambda. So that is new, right? You couldn't write PowerShell before. You can now take your regular PowerShell that you use every day, go put a script, and go publish it with Lambda, and go do something about that, that security incident that just happened. So Lambda is the answer for this, right? Lambda already has integration with config rules. When I wrote this slide There were about 60 rules built in, but now there are about 80. So it's already out today, right? There are 80 rules, so you don't have to write anything new. But if you want to start something new in PowerShell, you can go definitely do that, right? Go write this Lambda function to either go delete that security group rule, or maybe you want to use that Lambda function to go do something in layer 7, right? I'm seeing this IP hitting me, maybe something like a rate control, right? It's hitting me like no human can hit at layer 7, like you cannot hit a certain endpoint in a certain speed if you're a human. Only robots can do that, right? So if you see IPs like that, you can automatically take that IP and basically block that IP at layer 7, right? So WAF can do that. Lambda helps to do that, right? So that's one of the things. And that example screenshot over there is actually from the AWS console. You can see that there's already a script written. I'm not sure, maybe in Node.js, I'm not sure what it's written in, but basically you can do that. It doesn't delete anything, but it basically says these are the ports. If they come up, if you go open these ports up to 0.0.0/0 to the public internet, it'll basically tell you that, hey, these ports are open. Go do something, right? To show this, I've got a Lambda PowerShell demo that I'm going to do. I'm going to try and talk and do this demo so we are not running out of time here, and I'm keeping you away from beer and pub crawl, right?
You're just minutes away.
OK. All right, cool. So, so I've everything set up, but let me show you the code that I have. That's it. As simple as that. That's the power of PowerShell. It's very simple. You can actually write this in like 4 lines, but I wanted to make it look pretty, so I put a bunch of comments and stuff. But what I'm really doing there is I've got a bunch of ports. I'm taking it in a list. It's basically you can add how many ever ports you want and whatever ports you want. I didn't put 3389, but you can put 3389. You can put whatever ports in there. And I've defined a range. It's basically the public internet. And I've defined a protocol if it's TCP. And anytime I see any of those ports open to that range in that protocol, I want to delete it. That's all I want to do, right? So I'm going to take this. The name of the function is multi-port delete. That's what I called it. I'm going to take this, and I'm going to run it in PowerShell and publish it to Lambda. So what I'm going to do is you want to start your PowerShell, right? So this is PowerShell core, by the way. This is not PowerShell, your regular PowerShell. So this is PS core, which means which is where Microsoft's trying to take their PowerShell product to, right? So this works across all platforms. If you're a Mac user, you can run it. Linux, you can run it. Windows, of course, you can run it, right? So the only difference you will see between PowerShell and PowerShell core is when the console opens up, you will see this being run as PWSH versus PowerShell.exe, right? That's the difference. PWSH is basically PS core. PowerShell is PowerShell.exe. Cool. So one thing you have to do is you have to install the Lambda module. Once you have installed the Lambda module, you have to actually import that Lambda module. So that's what I'm going to do, import AWS Lambda PS core module. I'm going to hit that. And once it's done, it's fairly simple from that point. You're going to do a publish AWS Lambda, PowerShell Lambda, and then you're going to give it the script path, right, where your script really lives. My script lives in users, my username, and under a folder called Lambda scripts, and I call it multi-port delete.ps1. It's a PowerShell. And the next thing you want to do is you want to give the name of the Lambda function. This is the name of the Lambda function, so I'm going to call it reinvent live demo. And then I'm going to specify a region. I'm going to choose US West 2 because we are geographically and DNS, because of DNS proximity, which is Oregon, Portland, Oregon. I'm going to choose that, and that's the region I'm defining. And I'm going to hit enter, and then it's basically going to start doing its thing and start publishing it. It's going to stop for a couple seconds here in about 20 seconds because I didn't specify a role, so it's going to want to know what role do you want me to use. But while that's going, I want to get back into my console, and I want to set up something. I want to go to my, first I want to go to the Oregon region, which is US West 2. And what I'm going to do is I'm going to go to VPC, and I'm going to set up a dummy security group that you can basically see this Lambda function in action, right? So go to security group, and I'm going to create a new security group, and then I'm going to put reinvent demo from stage, right? Hope this works. All right?
You've got 20 seconds.
20 seconds here, right? And I'm going to put it in a random VPC. I've got a builder session. So I'm going to put it in the random VPC that got created. And now I'm going to look for that particular EC2, particular security group. Here it is. The description says hope it works, so we know it is correct. So now I'm going to go do add a rule, right? Let's, if you guys remember, I had port 25. And then I'm going to do 0, 0. I'm going to copy this. Oops. There you go. Right? Okay. I'm fat fingering way too much now. Okay. All right. Let's go add 1, 2, 3, 4 rules. Good enough, I think. We had 3306. We had 1433. And think we had 135. We had 1521 Oracle. Right? I'm going to put this in. And then I'm going to save this, and I'm going to come back to it, right? Now let's go look at the Lambda function. What happened there, right? So looks like it already took it, because maybe I ran it before. Yep, it took it. So let's go look at the Lambda function in US West 2. And sorry, I should have opened it up in a new tab. But I forgot, so just to show you, I'm going to go back to the security group here that we created, just to show you all of those rules that we created. So these are the rules. They are in there, right? All of them in there. Now, come to Lambda, and then just doing a quick refresh. There's a live demo. It was published about 2 minutes ago, so you know it's fresh. So you click on it, and basically you can go test, right? When you go test for the first time, it's going to ask for input, right? You can just, there's no input in this Lambda function. You can just go leave it default, the JSON file, click create, save it as no input, and it's saved there forever. So you can just keep using the no input. Go ahead and click test, and it's going to take a little bit of time. You know about cold start, and of course Firecracker is out now, but it's going to take maybe about a few seconds here to execute that Lambda command and Lambda function, and then it's going to go look across all of the AWS, all of this US West region to see if it found anything. So it looks like it executed correctly, and it says it found 4 TCP ports open, and it deleted 4 TCP ports in that particular, and it deleted in this hope this works security group. Now, if you go back there, it's still there. But if you hit refresh, it should disappear, right? So that's a pretty simple Lambda function that you can write in PowerShell now. That's the point I want to drive. You don't have to be worried about, I have to learn Python, I have to learn Node.js. If you're a Windows guy, you know PowerShell, start using it, right? So last slide here, just a bit of an eye chart, but I want to drive this point home. Every single slide Mark and I put together were basically with Windows operating system in our mind, right? That's what we did, right? So we wanted to throw everything that we have in AWS today that you can natively integrate and use to run your Windows workloads, and that's what we did. Starting all the way at the bottom, we didn't talk about some of these things, but those are, you know, this is a level 300 talk, so we figured you know security groups and you know NACLs and how they work. But Systems Manager, Amazon Inspector, if you can push it into your deployment and development life cycle, that's wonderful. And of course, securing identities is what Mark talked about in terms of using Active Directory and managing that user identity life cycle where it exists. Right? You don't have to create a brand new set of users for AWS and try to manage that. Genesis, decommissioning, all of the life cycle of that particular user identity lives right there in Active Directory. Right? So with that said, I want to wrap up with this slide. Windows is a first-class citizen on AWS, right? So that is one thing that we want to really leave you with. So if you're running Windows instances, definitely use all of these services that sit around Windows instances within AWS so you can be secure and you can be very scalable and highly available as well. With that said, thank you so much for picking us over beer and pub crawl. Certainly appreciate it. One last point, if you have a few minutes, few seconds, please do the eval from your app. We truly value your feedback, and thank you.
And again, there's a security workshop that you can go to. It's not Windows specific. It is Sec 337 R1 workshop at 6:15 to 8:30, Venetian 4th floor, Lambda 4205. So please visit them if you don't want to go to pub crawl. Thank you.
Yes.